So you went through the Plutus Pioneers program, you've done your homework, and now your code isn't compiling using the most recent version of Plutus. Welcome to the world of working with cutting-edge technology. My name is Matthias Sieber. I'm part of Gimbal Labs PPBL team, which is really all about Plutus learning. The idea is that we pick up where the Plutus Pioneers program left off and really create some interesting reusable use cases. Plutus project-based learning at Gimbal Labs is a space where anyone can develop a deeper understanding and get better at building with Plutus. And sometimes that means trying to build the things that worked before that do not work any longer with code changes, with breaking changes, because Plutus still to this day is very much in development, and it will be for the foreseeable future. Our aim is also to build an example of a repository of reusable open source Plutus components that are licensed under the Apache 2.0 license that will benefit the Cardano community. And also Gimbal Labs has a commercial interest. So part of the mission is really just to become Plutus experts. So it's both self-serving, but also, of course, for the greater community. So also the way the PPBL team works, we are incentivized to essentially create or solve these tasks and also document our solutions for these and share it with the community so that the Cardano developers or developers who want to become Cardano developers have something that can be replicated rather easily. What we're going to do is we are going to clone the Plutus starter repository that has the most recent Plutus version in it. And then we are going to grab the GiftContract from lesson 2 of the Plutus Pioneers program and just grab a solution there and try to make it compile. We might make some changes to the contract itself, and then we will deploy the contract via the PAB, really. Still on our local environment, but nonetheless, we are going to use the Plutus application backend. And then finally, we are going to test it. By test, I mean we are essentially querying the various endpoints using curl or whatever you see. And I expect things to break. I have not looked at the recent version of Plutus, any changes there. So it will be interesting to see whether we will make it compile and it actually behaves as we expect it to be, or if there are any surprises. You'll see. I hope this will be entertaining and educational for you. All right, I am on the page for the Plutus Starter GitHub repository from input.output Hong Kong, or IAG, or whichever. And usually what I do is I clone the repo. But here I notice there's this use this template function, and it even has VS Code dev containers and all that good stuff. Awesome. Yeah, I will not be using that, but feel free to use that. So I'm just gonna click on use this template. I'm just gonna put it to my personal GitHub and give it a name, just GiftContract -109, because that is the dev container version of the Plutus start. Don't really care right now. Sure, public, create a repo, and now we have our fork here. I'm just gonna clone this. Okay, clone this. Wonderful. I'm going to get into my working directory. So I like to work with something called Tmux. So let me just start a new session here. Gift. All right. The next step might take a while. What we're going to do is we enter the nix-shell. So I might come back tomorrow or something like that. It's ridiculous. I feel like my environment is not properly set up for this yet. Okay, next we are going to build the starter, essentially. So the command that we use is cabal build, and right now the target is called plutus-starter-pab. And I give it a couple of more arguments because my build process is very slow, despite having 16 processing units, so 8 cores actually. So anyway, so you don't have to do this, but I am going to pass in only dependencies, and then also to disable the documentation and only dependencies. Dependencies. All right. I've never seen this message before, so good thing it actually checks. Okay. So, and now we are cloning, and this is going to take a while. So I'm gonna stop the recording here right now, and I might be back tomorrow. All right, the compilation is finally done. No errors. Again, we didn't change anything in the code yet. That's what we're going to do next. And as for the next step, let me just pull this over again. So this is our GiftContract. We don't need that right now. Let's just look at the Plutus Pioneer Program. So in week 2, let's go to the solutions branch here and dive into the code. Week 2, source week 02. And let me check. It was either solution 1 or solution 2. Yeah, I think I want the other one. Let's go with solution 2. Okay, so this is a GiftContract with a typed validator, right? So one of the potential homework solutions. We are going to use that as a base and see what happens. So let me just copy this code. And now we will be opening the contract. Okay, so let's start our text editor. So in source mymodule.hs, this is where we want to put our code in here, right? So let me just replace this with what I just copied, save it. And now what we're going to try and do, actually, let's not do this right now. Let me just quit this for now and rebuild our starter. And the file name does not match the module name, right? So it's expected module, and we have week 02, solution 2. So let's actually fix that. But before I do that, I'm gonna start another nix-shell. All right, so what I did here, I just opened another terminal, started a nix-shell there as well, because I want to stay in the editor in one and do the compilation in the other. So let's go back here. So we have the error message, right? So let's go into my module again and just change the module, right, to my module. This is what was expected, right? Save that, and now rebuild this again, right? So about build, just start pab again. Only. No, disable documentation. Okay. All right, next error. We're making progress, right? Could not load module data taught text, right? So we use, in this solution, there is a requirement on a text module, which is not part of the starter, but we can add that rather easily. So let's go into the cabal.project. Is that the right one? No, that wasn't it. was the plutus-starter-pab. All right, this is the right one. Okay, in here you can also change, of course, author, maintainer, descriptions, all do that good stuff. We don't need to concern with us. Don't need to concern us with that right now. But under library, right, under this section here, this is where we can add the dependency. So let's just keep it in alphabetical order. So after Plutus ledger, just add text, save this, and rebuild. So resolving dependencies, text should be pulled down. Maybe it already worked in my cache or something. And now we are being presented with a bunch of other errors, which is great. This one is a curious one. UTXO add until recently has been actually been in scope. So looking forward to debug that. Perhaps you meant UTXO's add? Maybe. Let's try that. All right, let's go back. UTXO add, right? And the error message was, there you go. Perhaps you meant UTXO's add. All right, let's see if this changes anything. And actually, let me change something here. So I'm already getting tired of having to manually build this over and over. So what I want to do instead is I'm essentially just going to watch the my module.hs, and whenever I detect a change, that is when I am actually rebuilding right now. As long as there's so many errors, I think that's a reasonable approach. So I'm just going to do ls source my module.hs, then I pipe it, and then I use a tool called enter, ENTR, with the -r, and then after that, I have my command that I want to execute. All right. So it's compiling. We of course expect still all these endpoint errors that have something to do with contracts and promise. But let's see. Okay, so our UTXOs add might have done the trick. Next one is couldn't match expected type built-in data with actual type Plutus-TX data. So what we got is Plutus-TX data, but we want built-in data, right? So here it is, line 87. We have Plutus-TX dot to data. What we want to do is to build in data and save it. It's compiling again. Luckily, it doesn't have to pull all the dependencies every time. All right. Yeah, that seemed to have done it. Okay, so next we have a couple of complaints. Could match type, contract, unit, gift schema, text with promise. Then we have writer, S, stream, I don't know, schema, probably schema. Of course, schema. And error, right? Okay, so that is actually, so this type actually is not right anymore. So we can comment that out. And then what we can do is essentially, well, first of all, what we are trying to do here is we are really waiting for either a GIF or a grab, right? So we can actually essentially block this, for lack of a better terms. But yeah, I think blocking is an okay word to use here, even though I've been doing so much asynchronous programming and what I consider now traditional web technologies. But anyway, so we're just gonna log out a string, just using the built-in the string from the Haskell prelude, and we are setting waiting for either give or grab. Okay? That's our message. And then here, I like to use select list, and because it makes things a little bit cleaner. So we have our give prime and we have our grab prime. And we use the seek operator. We're not using bind here on this line. We don't need this. All right. Could match Plutus contract with endpoint redeemer. Okay, so what I think might be happening here is that the type of signature I actually need to define it. So we're almost there in here, but we will be essentially passing an error also. And this is actually a contract error. So as contract error is actually our constraint, our type constraint. And then this might work. All right. Yep. Okay, my Vim isn't complaining anymore. This seems to have worked, which is great. So now the contract compiles. So we are a step closer. I think there's just a couple more things that I want to do before we hook this up to the PAB. Just to give you a couple of ideas what we could improve. So if you look at the redeemer, right, remember this is kind of a silly redeemer. What I want to do here is let's just use a redeemer, still use a bool, but use one. Whenever we use a type that only has one type constructor, we can also use a new type, right? So instead of data my redeemer, I now have new type my redeemer. And that in itself is only going to have just one bool, right? And there's some compilation time benefits actually. Of course, now we have to also adjust the validator, right? So if you look at make validator, right, we have my redeemer, and then we say, okay, treat the first bool as what was flag 1 as B, and treat the other one, the second bool as C, right, which was flag 2. Now just B, right? And here we can just say still wrong the redeemer and just say we don't do a comparison, we just pass in B. So essentially what happens is that you pass in a payload into the redeemer of either true or false, right? And if it's false, well, it fails. Oh, this should, let's also change the comment here. This should validate if and only if, okay, this should validate if the bool is true. So we don't care about the public key hash. We have a very simple redeemer, right? And we don't care about the script context right now. Very simple, just trying to still make this compile. Okay, so the other thing that I want to change here is, even though it doesn't really matter in this case at all, but the word unstable, it's not very pleasant to read for me in Haskell code. Might as well write JavaScript. So what we can actually use is make is data indexed, and then remove one of the ticks here, and we pass in a tuple, my redeemer, and then the index will be 0. Again, it doesn't really matter in this case, but makes me just a little bit happier. And I think the final thing that I want to do is, right now we're exporting everything, and that is fine, but let's just restrict ourselves to just a couple of definitions. So we certainly need, so for the pab, we need the redeemer, we need the schema, and then the endpoints, and that's what we're going to export. So we have endpoints, let's see, the gift schema, and then my redeemer, and everything what is attached to that, or what comes with that rather. Okay. And I think that's it for today. Let me just make sure. All right, it compiles, which is great. Next, we're gonna hook up the pab, and then we're gonna test it. So next, we want to serve this contract not through the simulator, which we could do by just copy and pasting the code, just like we did in the starting lessons of the Plutus Pioneer program. But we want to serve this through the Plutus application backend. So to do that, we have to modify the main .hs, which we find in the pab directory. So first, what we should be doing is let's look at line 11. We don't need to export write costing script. We don't care about that. And we can also remove this from here. A couple of comments that do not really apply to us. So there we have writing costing script. So all of that can be removed. We're not going to use that. Then let's go back to the top on line 27, right? So the Plutus starter code ships with a game contract, which we are not interested in. So we are just importing our script. We named it my module. So I'm gonna import my module here. And of course, if you were to be closer to Plutus contracts, Gift, for example, you would import that. Then also your file structure would change. But in this file, there's still many references to game. But what we can actually do is just replace the word game with gift here. We got 8 substitutions on 5 lines. And then we're not done yet. Actually, in this block, which is now for me lines 65 through line 70, there are a couple of things that do not line up quite nice because the gift schema is not part of gift, but of my module, right? So we're gonna change that, my module, and then also on line 70, right? It's still not gift, but my module. And I'll replace the game. Game actually, if we look at this, are really the endpoints, but let's open the game contract up. Get an idea. So game address, here we have, right? So line 166 through 169 looks fairly similar to our select list. Not quite the same, but similar. So we say we name this endpoints. There's a warning. There is a unused language pragma. Let's remove this. All right. All right, so now that we have built the contract, the PAB, let's actually try and test this. So first of all, again, let's rebuild pub just to make sure it's up to date. And then we are going to run the server. Right, so to do that, we run cabal exec. Oh, let me switch to the console. There we go. Cabal exec and then dash dash. Actually, this one too, but official it's space dash dash, another space, and then the target, which is plutus-starter-pab. Right, and that just launches a HTTP server essentially. So now we have the backend started. What we can do, since this is based on the simulation code here, we are actually starting the server, and then we are waiting for a get line. So you can just type anything in, hit enter, and print out the balances at the end of the life of the server. And then we shut it down. All right. So let's just do that for now. Just hit enter, and we see 10 wallets. Let's start a server again. The way to create wallets is documented in the README. And to create wallets, just a curl command. It's a post request. But no payload is given, which is unusual, but oh well. And so you just hit the create endpoint, or the wallet create endpoint, and then you pipe that through the JQ tool to get the wallet ID to. So let's actually run this curl command. All right. So what you can see here, we have a JSON object that we get back, and we have this wallet key, WI wallet. And then within that, we have the get wallet ID. And we want to use this value. Right, so this is what this line does, and it actually puts the value in the environment variable as wallet ID 1. And then we use that ID in the next call and on the contract. So this is, of course, the game contract. We haven't changed the documentation here at all. This is based on the example contract, game contract. So we'll, of course, use GiftContract and again, use our wallet ID and so on. And that will give us an object as well, and we can use that to check the status essentially of this instance ID, which we'll get back. So we cannot simply just use the wallet ID and use that in our contracts. We have to activate the contract with our wallet ID, and we get a UUID and aka an instance ID in this instance. And then we use that for our actual contracts. And then, yeah, so from point 4 on, this does not apply to us at all, but it's worth looking at this anyway if you haven't done this already, because this also changes. All right, so to make things a little bit easier, I just created a shell script. I'm going to create 4 wallets here. I'm going to activate the gift contract on those 4 wallets using the wallet ID, which I receive from the first 4 calls respectively. And then I'm trying wallet 1 and wallet 2, both try to give some loveless. Wallet 3 is unsuccessfully trying to retrieve the funds that are locked in the script because we have the string false, it gets passed through, it's converted to a bool, which will evaluate to the false value, and thus the valid data fails. So the redeemer will return false. So thus, no funds should be retrieved by wallet 3, but then wallet 4 is passing the correct payload, just with the word true. And that is essentially it. Now, I expect a couple of hiccups, but first and foremost, let me actually define how much loveless I want to send through. So we can see, right, this is the value. So let's just do this instead. And I think, yeah, now we can try it. So let me actually shut this down real quick, clear this, and make sure that my script is executable. Then I am going to restart the pab. And now I'm gonna run the script. Oh, actually, let me do one more thing. Okay, one more thing. I also want to print out the wallet. What do I want to print out? The wallet IDs or the instance IDs? Let's do the wallet IDs. All right, good enough. So let's run this. So we are creating wallets, then we activate our contracts, and we also see that, all right, there's a status waiting for give or grab for these instances. And then afterwards, after 4 seconds or so, we have our first response, a gift of however Lovelace that was the second one. Now, wallet 3 has a wrong redeemer, so this fails. And finally, we have wallet 4 collecting the gifts. Okay, so on the right hand side, we also have the hashes of the wallets, 4 in total. So by the way, these square brackets output, you can think of these as successful API calls. So let me hit enter to return the balances and shut down the server. Okay, this looks odd. Hooray. Let's see what's going on here, right? Let's count the wallets. This might have changed already from the previous version. Well, it actually has, because we had to create the wallets a little bit different and then activate them. Before we just had to create wallet and then a numeric, so just an integer essentially, to say, okay, activate wallet number 1, and I think you had 10 per default anyway, so yeah. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Interesting. All right. So now let's look at wallet 1, which is this one. Okay, so this is the balance here of wallet 1, right? So let's try and make sense of this. So this is the starting value, right? We can probably agree on that. And then the end value. So we want to end. I'm probably offending someone with my spelling. So if we say start and the end, okay, it looks almost familiar. So if we look at how much, nope. What is going on? All right. So we have start and negative. That is, this is 0 more than we originally had. This fluctuating. Okay, so this is very interesting, right? So something is clearly happening that I do not understand, because if you look at the balances, what I would have expected to see is wallet 4. First of all, let's look at wallet 4, which should be this one, but I'm afraid this is a new wallet with less funds than the other started out with. Oops. So there we have it. And yeah, we can already see it, right? This is less than what the other wallets started out with. And if we remember, wallet 4, however, right, is the wallet that I actually only grabbed stuff. So something changed here. I mean, it says still wallet everywhere, and it doesn't say like UTXO or anything like that. But I'm not understanding this part right now. All right, we're back. We did some deeper digging. I connected with a few other PPBL team members, and so what I found out is, looking at the numbers a little bit and did some additional testing, which I have documented, and I'll provide a link for you, is that essentially we noticed that when we start the PAB simulator, 10 wallets get created, and those 10 wallets each hold 100,000 ADA as initial account balance. And then what we found out as we, in our script, because now things changed, right? We had to get a different ID on wallet creation and use that ID for the activating the contract. Previously, before version 109, we could just say, oh, create wallet number 1, right, using an integer. And that is not the way to create wallets apparently anymore. So we had to create 4 wallets, or we had to create additional wallets and actually use those to use the contract. So there might have been other ways, but documentation is not as accessible yet, and quite frankly, not really usable for these kinds of works. Didn't find anything in the changelog. But anyway, so what we found is that for the first 3 wallets that we manually created, a balance of 10,000 ADA each was put into this wallet. And then the last wallet was actually close to 60,000 ADA, right? It was actually 60,000 minus 40 Lovelace. So like a 40 a fee essentially. You can see that in the simulator. You see a lot of fees in the amount of 10 Lovelace per transaction. So that was very interesting because if you take all that together, the balances of the 4 manually created wallets by hitting the wallet create endpoint and subtract 40 Lovelace, add 40 Lovelace to that balance as well, then you end up at $100,000. $100,000. That'd be terrible. 100,000 ADA, right? So what I end up doing was to create a bug report. Actually, after I put a Cardano Stack Exchange post on it, I won't click on this because the site doesn't have dark mode yet, as I understand it. And long story short, this sucks. And it would be, I think, beneficial to say, hey, create a new wallet, give some Lovelace in there, right? And you can specify that amount. Because it's not the same for the other 10 default wallets. I'm sure there are ways, yes, you can do it. It's just really hard right now, right? This is the frustration that we are dealing with. We want to write cool stuff, yet we are stumbling over these basic things. And I'm positive things will get better, will stabilize, and all the good stuff. But right now, this is the approach. So bug report is out, but we're not done yet. We still want to see that this works. So what my team member Ganesh did was he created an inspect endpoint. So let's look at that. So here's the PR which we already merged in. Let me get out of the way here so you can see this better. All right, so a couple of new packages. We have Lens, which is a popular Haskell library. And then he also provided a different shell script. Essentially does the same thing, different sleep values, because here we actually we wait on key press, right? So a little bit nicer here. So yeah, I would say let's try and run this. And here in my module, right? This is where our contract lives. Changed some stuff around, which is fine. And the big part here is that we have a new inspect endpoint, right? And that gets added to the endpoints list, of course, and here's the functionality. All right, so I'm just gonna do a git pull, not a git fetch, and all of that stuff. So pull everything down here essentially. And let's run a script. We start the same way. Creation of 4 wallets, activating the GiftContract, and now in the script that Ganesh provided, right? It's a little bit more explanation what's going on. So next, inspect endpoint will be invoked for wallet 3 and 4 to log the total value in them, right? Press any key to continue. Let's do that. Okay, so here, let's grab our initial value here. And let's just go to so initial is this value, right? And we can see this is the same for wallet 3 and 4, right? So this should be 10,000 ADA. 1 million Lovelace, 1 ADA. Okay, so now we are going to put some Lovelaces to the script address, right? So we are making gift, right? Wallet 1 and wallet 2 each make their gift, right? So here. And then next we will see that when wallet 3 tries to grab with an incorrect redeemer, the transaction fails. All right, so we see that here because we have all false. Right, so I really like this. This is a really good demo. So thank you, Ganesh. All right, so we have our wrong redeemer here, right? Next, wallet 4 tries to grab the funds to the script with a valid value for the redeemer and succeeds, right? Because we can see that we actually sent true, right, on line 49. So let's continue. Right, collected gifts, wonderful. And finally, we inspect the funds in the wallet. Right, actually, let me grab this one real quick. Because that was the gift value. One gift value. And now here we have the final value of wallet 4. All right, so finally we inspect the funds in the wallet 4. So this is a different endpoint, the inspect endpoint that we provided. All right, so let's get that W4. Yeah, so let's see what we have. So we have W4, right? And then minus. And then we have our initial value plus 2 times the gift, right? This is what we are collecting, right? And so now we have negative 7,164. So that would mean 7,164 Lovelace are not accounted for. And those are most likely fees. Right, let's see actually if we can spot something in the logs. Let's uploads. Okay, there are fees here, but let's see anything. Empty map. Okay. Well, that's unfortunate. I would have expected fees to carry the actual values in here, but maybe I've looked at this too long and I look at the wrong place. Maybe. I'm not sure. But, you know, I mean, if you think about it, right, 7,164 Lovelace. Like I said, 1 million Lovelace. That's 1 ADA. So, seems about right. I think this is good enough. Oh, and then, of course, let's go back here, press any key to continue. Okay, let's stop the server. Well, I did say we don't need it right now, but let's actually look at wallet 4 again. So there it is, right? So this is, in fact, the number that we saw. Yes. Okay. So great. The only thing that really made this difficult for me is really the inconsistency in the amount of Lovelace in the wallets, right? The simulation versus now with a new way of manually creating the wallets, essentially following the docs. And yeah, well, we'll see. I'm sure there will be updates in the future. So that's why I figured I'm gonna keep this part in the cut of the video, because I think it's also important to see some of the struggles and how we overcome them. And the answer here in overcoming this hurdle was actually community, right? It was a one-man effort. I'm still learning myself, right? I have other team members that contributed to this, and so big thanks to Ganesh who took time, and also Eli looking into this. And yeah, I hope this was useful. I hope this is going to be easier from moving forward. And like I said, I think it will be. The ecosystem is growing. More tools will be made available. Our team's gonna provide some tooling as well. But let's do baby steps. Thanks a lot.